In this video, we outline the best practices for optimizing wireless performance on your Grandstream GWN devices. We'll cover essential deployment steps that you need to consider to effectively plan, install, and configure a Wi-Fi network. These steps involve conducting a site survey, strategically placing access points, managing radio frequency, and more. By following these guidelines, you can build a stable, efficient, and high-performing wireless network. A great wireless network starts with a great wireless design. To design a successful wireless network, it is important to understand the business requirements for wireless connectivity, such as capacity, coverage needs, and application requirements. Designing a high-performing wireless network involves conducting a wireless site survey. The goal of a site survey is to determine the optimal placement of access points and how many are needed for adequate wireless coverage. The facility layout, existing structures, and building materials must also be taken into consideration when designing a wireless network. The Grandstream Cloud Platform, GDMS Networking, offers the floor plan tool that can help with your predictive site survey. It can be used to create an approximate representation of the wireless signal strength and coverage within a physical location. The tool helps you simulate access points placement on a floor plan to determine the best placement for signal propagation, coverage area, and the number of access points needed. To watch the full video guide of the GDMS floor plan, please use the link in the description. Based on the predictive survey results, adjust the placement of your access points to ensure better coverage. This could mean relocating APs to areas with poor signal strength or moving them away from interference sources. This is crucial for minimizing dead zones and improving overall network performance. Here are some best practices regarding access point placement. The recommended placement of GWN indoor access points is on the ceiling, as this allows even signal propagation throughout the area. For GWN outdoor access points, they should be mounted directly on walls or poles. Grandstream Networks also offers several indoor wall mount access points, such as GWN 7661. An indoor access point should be mounted no higher than 25 feet above the floor. The higher the access point, the longer the distance between the access point and the wireless client. Please keep in mind that distance is a natural cause of signal attenuation. In a situation where the ceiling is too high, the indoor access point can be mounted sufficiently high on a wall. Avoid placing access points near materials or objects that can obstruct or attenuate the signal. Whenever possible, position access points with a clear line of sight to the areas they serve. This reduces signal degradation and helps maintain consistent coverage. Obstructions like furniture, walls, or large equipment can cause the signal to scatter or weaken, leading to poor performance. Mount an access point at least few feet away from any source of interference, such as electrical conduit, AC ducts, microwave ovens, etc. Heat exhaust fans might not necessarily cause interference, but it could lead to overheating access points mounted too close. To prevent signal drops during roaming, it is recommended to maintain a 15 to 20% overlap. This ensures a wireless client can detect and connect to an adjacent access point while still being connected to the active access point. In addition to these best practices regarding access point placement and wireless coverage optimization, a wireless administrator should also consider the capacity factor when deploying access points. Wireless capacity requirements will have a significant impact on how you design for coverage. More importantly, coverage is not just about client connectivity, but also about client performance. An optimized coverage means the wireless client can roam efficiently while still performing at high data rates. Identifying the number of concurrent wireless connections and the required bandwidth, at any given time, will determine the GWN access point model needed for your deployment. Grandstream offers a wide range of access points designed to meet the needs of low to high density wireless environments. For example, GWN 7605 is designed for small to medium user density, while GWN 7664 is ideal for medium to high density deployments. An access point capacity is generally influenced by the Wi-Fi standards it supports, the number of built-in spatial streams, and the type of MIMO technology it uses. Multiple spatial streams with multi-user MIMO technology allow an access point to communicate with more clients simultaneously, which significantly increases the overall wireless throughput and reduces congestion. In addition to meeting the coverage and capacity requirements, a wireless administrator should understand the type of applications and devices that will be used over the wireless network. Device compatibility with the access point's Wi-Fi standards and features is crucial to determine the configuration parameters that should be enabled for Wi-Fi connection. For instance, a wireless network cannot be configured to strictly use 5 GHz or 6 GHz when there are devices that only support or work better with 2.4 GHz. Also, enabling security features such as 802.11w can improve Wi-Fi security by protecting management frames. However, some legacy devices may fail to connect if 802.11w is enabled on the access point. Some Wi-Fi features are not universally supported by all wireless clients, and they should only be enabled after confirming clients' compatibility. In this section of the video guide, we learn about radio frequency management in a wireless network to ensure reliable and high-performing wireless connectivity. This involves selecting appropriate channels and tuning transmission power. These adjustments are made based on the information learned from the site survey during the pre-install and post-install phases. There are many third-party tools that you can use to help you conduct a site survey. These tools can be used to analyze and visualize wireless coverage, identify interference, and flag any security weaknesses. The primary goals behind doing a site survey and adjusting the Wi-Fi parameters in a GWN access point are to minimize interference, optimize coverage, and increase throughput. Making these adjustments requires a basic understanding of the radio frequencies used in Wi-Fi. You can watch the video guide about Wi-Fi frequency bands in the description to learn more about the channels and bands used in Wi-Fi communication. We will use the Grandstream Cloud Management Platform GDMS networking to illustrate how to adjust the radio frequency parameters and explain their functionality. The global radio settings are available under Settings, Wi-Fi. The global parameters configured under this page will automatically apply to all the GWN devices under the selected network. If you need to apply changes to a particular GWN device, you can use Devices Configuration page. We start with band steering, which is a technique that encourages multi-band devices to connect to a specific band. Wireless administrators generally configure band steering to prioritize 5 GHz to minimize the number of devices using the 2.4 GHz band, which is usually more congested. As illustrated here, without band steering, the wireless client listens to probes from both bands, 2.4 GHz and 5 GHz, and makes the decision to connect to the strongest band. Some wireless clients might connect to 2.4 even if the band is congested and overutilized, even if it's within range of the 5 GHz band, which can offer a better data transmission rate. With band steering set to prioritize 5 GHz, the access point will not probe on the 2.4 band, and it will initially respond only to probes on the 5 GHz band. It will delay 2.4 GHz probes, so clients are more apt to choose 5 GHz, which is less congested and more resilient to interference. While designed to enhance Wi-Fi performance, band steering has potential downsides. Some wireless clients may struggle to connect to the prioritized band, especially during the roaming process. Other clients may not fully support access point steering, leading to unstable connection or compatibility issues. Having said that, band steering is a convenient way to prioritize which band the wireless clients use, but it is always the wireless client that makes the final decision about which band to connect to. Client steering can also be enabled with band steering. This feature allows the access point to direct wireless clients to an adjacent access point with a better signal when one of the specified thresholds are reached. For instance, with this setup, when the detected client RSSI is -75 or lower, the access point will direct the client to roam to a neighboring access point by providing information about neighboring access points such as their BSSID and active channel. It helps a wireless client quickly find the best access point to connect to, leading to fast roaming. The wireless administrator must ensure that access point cells are overlapping at an RSSI value higher than the one configured here. For instance, if the RSSI threshold is set to -80, the cells should overlap at -78 or higher. The access threshold should be properly configured for better load balancing of wireless clients. While client steering can help reduce congestion and simplify roaming, it may cause issues with devices that do not support 802.11k, which is the standard used by the access point to steer clients. For clients that lack 802.11k, they will not be able to determine where to steer or might not even know that they need steering. The next feature is airtime fairness. In wireless communication, only one device can transmit at a time. So, when a slow transmitting device joins a wireless network, it will take longer airtime to transmit data. This causes other devices to wait longer until the slow device completes the transmission of its block of data. To solve this performance problem, airtime fairness can be enabled to equally divide the airtime between devices. It prevents slower devices from monopolizing the airtime and negatively impacting the overall network performance. The parameters under the radio configuration page will apply globally to all the GWN devices in this network. If you need to implement changes to the radio settings for a particular GWN device, go to Devices menu and select the GWN device and make the necessary changes. The 2.4 band has a limited number of non-overlapping channels, making wider channels less practical. When deploying multiple GWN access points in a facility, always use the 20 MHz channel. For channel selection, there are 3 methods that you can use. Auto channel selection will do a quick scan of available channels and pick the least congested. In this mode, the GWN access point selects the channel one time after provisioning or booting up and continues using it. RRM, or Radio Resource Management, continuously monitors and analyzes the wireless environment and dynamically changes channel selection to the most optimal channel. In a multi-access point deployment, RRM selects the best channel for each access point based on factors such as interference, noise, and congestion. While RRM is designed to optimize network performance by dynamically adjusting channel selection, it can also introduce some downsides. In a wireless environment with excessive radio frequency interference, the access points may frequently switch channels. This will cause wireless clients to disconnect and reconnect as the channel changes, leading to intermittent connectivity issues. In addition, some legacy devices may struggle to switch channels. The third method is the manual selection of channels, which is available only under GWN device configuration page. Experienced administrators who understand Wi-Fi channels and their behavior may choose manual selection to optimize channel use in certain areas in the wireless network. Based on the information learned from the site survey, an administrator might need to adjust the radio power of the access points. Keeping the transmit power at a moderate level ensures a balance between coverage and interference. High power can cause excessive overlap between access points, leading to co-channel interference or contention over the same channel. A common pitfall is over-tuning the radio's transmission power. If the transmit power is too high, clients may struggle to communicate back to the AP. This is due to client devices typically having lower transmit powers compared to wireless access points. As a result, an access point may be able to send data that reaches the client, but the client is physically unable to reach the access point with its reply. In addition to dynamic channel selection, RRM can be enabled to dynamically set the transmit power level of each access point. Experienced wireless administrators may opt to set the transmit power level by selecting from the predefined settings, low, medium, high, or by entering a specific dBm value. Clients that transmit on lower data rates consume excessive airtime, which can degrade the overall performance of the wireless network due to bottlenecking. You can improve the performance of the wireless network by establishing a minimum data rate or a minimum RSSI. Removing support for slower data rates can force clients to roam to neighboring access points with stronger signals. The logic of minimum RSSI is that the access point will send a management frame with deassociation to notify the wireless client to disconnect when the minimum RSSI is reached. But the handling of this management frame varies across different wireless clients. The value used for minimum RSSI must be carefully chosen. For example, if you set the value -75, you need to ensure the active and the neighboring access point are overlapping at a higher value as illustrated here. While Wi-Fi 6 and 7 are designed with backward compatibility, some legacy devices might experience slower speeds or connectivity issues when Wi-Fi 6 or 7 are enabled on the access point. You can use this feature to disable Wi-Fi 6 and 7 capabilities and force the access point to use Wi-Fi 5 instead. The radio frequency parameters that you can configure under the global radio settings will automatically apply to all access points added to this network. There are configuration parameters that are specific to an SSID, and these are available under wireless LAN configuration. In addition to the security and control settings that are configured for the SSID, there is the Voice Enterprise feature that we strongly recommend to enable for roaming devices. This feature is designed to reduce the time needed for a device to roam from one GWN access point to another. It is based on the wireless standards 802.11k, R, and V. This is particularly useful for delay-sensitive applications such as voice and video. To learn more about this feature, please watch the video guide about roaming in the description. This wraps up this tutorial that covers the basic guidelines for planning, installing, and configuring GWN access points. Thank you very much for watching.